Hello everyone, for this tutorial video I'd like to discuss completing the square, which is a specialized, more complicated method of solving quadratic equations. In particular, we remember that a quadratic equation in standard form is ax squared plus bx plus c equals 0. So if we are given something like x squared plus b times x, with no constants, we may get concerned at first because it doesn't look like a quadratic equation, but if we remember, for example, that x plus 2 times x plus 2, or x plus 2 squared, is x squared plus 2x plus 2x equals x squared plus 4x plus 4, then it should follow a general formula is x squared plus b times x plus b divided by 2 squared equals x plus b divided by 2 all squared. So a conclusion, if we add b divided by 2 to x squared plus b times x for the constant, and then square that constant, we complete the square. And it is called completing the square because we are condensing a quadratic equation into a sum of two terms, the result squared. So if we are asked to complete the square of a specific example like this, we would plug in the formula b divided by 2. So in this case we get negative 8. We square it, we get 64. So now we add 64 to get it in terms of a quadratic expression. And then see, it condenses to x minus 8 squared. So now that we know how and why completing the square works, we can use it as another method for solving quadratic equations. As in this example, we see that factoring or using the square root property may be tedious or not even give us an answer at all. So we will use completing the square for something complicated like this. In particular, we rearrange it so that negative 1 is on the right hand side. See that b is negative 6. So negative 6 divided by 2 squared is negative 3 squared equals 9. We add 9 to both sides. See that the left hand side condenses into a perfect square, and the right hand side is still a constant, albeit a different constant than we were given in the problem. So now we have it simplified enough that we can use the square root property directly and get x equals 3 plus or minus the square root of 8. If we have a problem with the coefficient of a different than 1, and that cannot be solved using the AC method, we would first divide everything by the coefficient to get it in a more simplified term where the coefficient of x squared is 1. Then subtract the constant on the right hand side. See that b is 3, so 3 divided by 2 squared is 9/4. Add this to both sides. Condense the left hand side to a perfect square, and then use the square root property to get an exact value of x. Although completing the square does help you with more complex quadratic expressions that cannot be simplified using factoring or the square root property directly, it does not work for every single quadratic expression. So we will have to derive a final formula that works for the most complicated types of quadratic equations, but that works for the more simpler ones at the same time. So, as a sort of universal formula that works for all of them, similar to how x equals negative b over a is a universal answer for any linear equation. The proof of this special formula involves completing the square, which we will see when we do the proof. In particular, if we start off with the general formula for a quadratic equation in standard form, we can see, like we did in the previous example, that we can divide all terms by a to get it into something we can use completing the square with. When we do this, we subtract c over a. See that b over a is our b here, so b over a times 1/2 is b over 2a. b over 2a squared is b squared over 4a squared. And as always when completing the square, we add this on the right hand side as well. We can condense the left hand side into a perfect square and simplify the right hand side using the least common denominator. The b squared part already has the least common denominator, but we multiply the c by 4a, and then we combine this into one fraction. Take the positive or negative square root of this fraction to get rid of the squared on the left hand side. Get x by itself by subtracting this by b over 2 times a, and see that fortunately for us we have identical denominators, with these two terms added or subtracted as appropriate. So we get our final result for the exact value of x in any quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. This formula looks very awkward and messy, but it is the exact actual formula for the solution to any quadratic equation, because we just proved why it is like this. Now that we have figured out more complicated formulas / solutions for quadratic equations, we can explain scenarios that involve applications of quadratic equations so that it does not just sound like abstract nonsense. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.